Episode 11 Saturday Special. Before Semiconductors. Passive Power to Vacuum Tubes. Crash Course Instrumentation. History Special. Hook. Imagine building radios, telephones, and even early computers with no transistors and no chips. How did engineers pull it off? With passive parts, magnetism, clever switching, and finally the warm glow of vacuum tubes. Roadmap. Quick and fun. Sparks, steady current, magnetism, passive signal tricks, power shifting, relay logic, the vacuum tube leap. From sparks to steady current, 1700s, early 1800s. Leyden jars were the first reusable, early capacitors that stored static charge for quick bursts. Experimenters even used them in electrostatic telegraph demos. Charge a wire from a friction machine, store it in jars, then discharge at the far end to pop a spark or move a pith ball. Proof that messages could ride on electricity. Then Volta's pile arrived and turned electricity from a parlor trick into a steady source. Reliable batteries made long-distance practical telegraphy possible, the ancestor of every battery-powered meter we use today. Magnetism joins the party, 1820s to 1830s. Oersted shows that current nudges a compass needle. Faraday discovers induction. Suddenly we get electromagnets, transformers, motors, and the idea that changing magnetism can move energy without touch. Power could be sent, stepped up or down, and safely isolated. Measuring with passive parts, 1830s, 1880s. Wheatstone bridges let technicians compare unknown resistances to known ones. No active parts required, just ratios. Telegraph lines stretched for hundreds of miles. Techs battled line resistance, leakage, and lightning, using resistor networks, careful grounding, and arresters, pure passive engineering keeping signals alive. Signals with just R, L, and C, late 1800s. RC and LC filters shaped audio from muddy to clear. Tuned circuits plucked a single radio station from the noise with a coil and a capacitor. Resonators, first tuned coils, then quartz, kept gear on time before crystal oscillators took over. Moving power around without electronics, transformers stepped voltage up or down and isolated dangerous circuits, still everyday lifesavers. Motor generator sets and rotary converters swapped direct current and alternating current long before silicon rectifiers existed. Mercury arc rectifiers brought industrial direct current from alternating current mains, giant glowing diodes that ran streetcars and factory drives. Switching and logic before transistors. Relays, electromagnets that pull contacts, became the first practical electrical logic gates. Telephone exchanges, railroad signals, and tabulators clicked along on relay logic. Early computers like the Harvard Mark I mixed relays and mechanics, slow, yes, but reliable enough to change the world. Changing signals without amplifiers, carbon microphones, changed resistance with sound pressure, letting voices ride on wires. Coherers and magnetic detectors sensed radio waves with clever physics, no semiconductors required. The vacuum tube leap, 1880s, 1940s. The Edison effect hinted that electrons can fly in a vacuum. The Fleming valve, vacuum tube diode, made one-way current, cleaning up detectors and power supplies. The DeForest triode added a control grid so circuits could amplify and oscillate. Radio, long-distance telephony, radar, and early computers exploded into possibility. With feedback and regeneration, sensitivity jumped. Super heterodyne, receivers made tuning sharp and stable. Why this still matters to INAMP techs? Those passive tricks, filters, bridges, transformers, relays, still fill panels and plant floors. Understanding them makes modern gear less mysterious and troubleshooting much faster. Rapid timeline, popcorn version. Leyden jar, Volta battery, Oersted and amp, Faraday, bridges and amp, telegraph, filters and amp, tuning, transformers and amp, converters, relays and amp, early logic, Fleming diode, triode and amp, radio, radar and amp, early computers. Takeaways you can say out loud. Sources: batteries and generators provide steady energy. Motion and amp switching. Magnetism moves things, relays decide things. Shaping, resistors, inductors, and capacitors sculpt signals. Leap, vacuum tubes add amplification and control. Outro plus teaser. If you liked this tour, tell us your favorite pre-transistor hack. Next time, we will peek at how the vacuum tube ruled the early amplifier era, and why some audio pros still love the sound today. Thank you to Tony Kuphaldt and the open source community for the ModEL resources that inspire this channel.